In this video, we'll learn how to create a logical partition using Ansible. Ansible is an open-source software that enables infrastructure as code. It helps with provisioning, configuration management, and application deployment. Ansible is extremely extensible. Third parties can develop modules and plugins to manage a wide variety of systems. Modules and plugins can be grouped in a collection, and collections can be shared on a central repository called Ansible Galaxy. IBM maintains the Power HMC collection that helps performing a lot of operations on a hardware management console from Ansible. A big part of working with Ansible is writing and using playbooks. Playbooks are text files written in YAML that contain a list of tasks to be executed. It is possible to write playbooks that are idempotent, meaning that running a playbook multiple times will not change the result beyond the first execution. Be warned that it is very possible to write playbooks that are not idempotent, voluntarily or not. A playbook is executed on the control node. The control node is a Linux or Unix-like system, for example, AIX or IBM I. It can be run on a Windows system via the Windows subsystem for Linux, WSL. Ansible is mostly agentless, meaning there is no need to install anything on a system that's managed by Ansible. You generally only need to install Ansible on the control node. The control node can be the administrator workstation or a management server. Most Linux distributions have a package called Ansible that can be installed via the distribution package manager. Without further ado, let's jump in and start installing Ansible on our workstation. On a Debian-like system like mine, we will use apt to install the Ansible package and its dependencies. If you have an RPM-based distribution, like Red Hat or OpenSUSE for example, you'd rather use DNF or yum. AIX will also use DNF and IBM I will use yum. When the package is installed, we can check that it's working correctly by running Ansible --version. This displays the Ansible version. Before being able to use an Ansible collection, it must be installed. For that, we'll use the Ansible-Galaxy command. We specify collection, install, and the name of the collection. In our case, IBM.power_HMC. Ansible is now ready to be used. Let's create our first playbook. Use your favorite text editor and open a file that must have an extension .yaml. Ansible normally works with an inventory of the managed systems and automatically runs playbooks against this inventory. Unfortunately, the HMC has a restricted shell that prevents Ansible from using its normal mechanisms. Our playbook will therefore run with the control node as the target. That's why we indicate localhost as the host. We indicate a local connection since we don't need to connect to a remote system. We also disable fact gathering since we don't need them. We will need the HMC password, but we don't want to store it in clear text. Ansible has several ways to handle secrets securely. For now, we will ask the user to enter the password when the playbook is executed. We now create our task. We give it a meaningful name. We then indicate the name of the module. In our case, powerVM_LPAR_instance in the IBM.power_HMC collection. We specify the hostname or IP address of the HMC. Next is the authentication information for the HMC. First the username, then the password. For the latter, we use double curly braces to indicate we're using a variable. Since curly braces are special characters in YAML, we must use single quotes around the value. We indicate the name of the Power server to create the partition on. In my case, S1022. VM_name contains the name of the VM to create. input. Then we list the VLANs the partition needs to access. We must enter the name of the VLAN as it appears in the HMC enhanced interface, not simply the VLAN ID. Our LPAR will use NPIV. We indicate the name of the VIOS and the name of the physical port to use. We create a second connection through the first VIOS, and we create two connections on the second VIOS for full redundancy. We indicate the operating system type for the LPAR, IBM in my case. You can use AIX, Linux, or AIX_Linux for an AIX or Linux partition. We specify the shared processor pool to use. Next, we specify the processing units for the partitions, the maximum value, the minimum value, and the desired value. We do the same thing for the virtual processors, maximum, minimum, and desired values. Next is memory. Again, we indicate the maximum, minimum, and desired value. Memory is entered in megabytes. Finally, we indicate that we want the partition to be present. Our playbook is now complete. We simply save it. I open my HMC interface on the right and set a filter on the LPAR name. Our test partition will appear once it's created. To execute a playbook, we run the command Ansible playbook followed by the name of the playbook. The first two warnings are from Ansible complaining that we don't have an inventory. Since we're not using Ansible inventory, they can safely be ignored. The third warning is a Python package complaining about a dependency unsupported version. We can ignore it too. Ansible prompts us to enter the HMC password. We type it. By default, the value entered is not displayed on screen. Once the password is entered, Ansible creates the LPAR. Let's fast forward to the end. The playbook completed successfully. Ansible informs us that a modification was done with the status changed. We can inspect the LPAR that was just created. Currently, the power_HMC collection can't set tagged IO for an IBM LPAR. This has to be done manually in the HMC. Minimally, we need to indicate a load source adapter. If we run the playbook a second time, the status of the task is OK instead of changed. This is Ansible telling us that nothing needed to be done since the partition already exists. Our playbook is idempotent. We will now create a new playbook to delete a logical partition. To save time, let's copy our first playbook and edit the copy. We simply update the name of the task. We can keep the HMC information as well as the name of the power server and the logical partition. We can remove the configuration information since we don't need them to delete the partition. We change the state value from present to absent and save the file. We now execute this new playbook with the Ansible playbook command. Ansible informs us that a modification was made with the changed status. On the HMC, we see that the partition was deleted. If we run the playbook a second time, once again, we see that the status is OK because the partition had already been deleted. This second playbook is also idempotent. There's a lot of freely available information about Ansible. You'll find the links in the description below. The first site is the Ansible documentation website. Next is the Power HMC collection documentation available on Ansible Galaxy. It contains information about all the modules and plugins the collection provides. Each module contains a list and a description of the parameters it accepts. Finally, the Using Ansible for Automation with IBM Power Systems Redbook contains a lot of practical information to manage the power server as well as the operating systems. I hope you enjoyed this video and that I will see you soon on 01BN.